We're going to move on to integrals that require us to use a technique called substitution. Here we have an example of an integral x squared plus 1 raised to the third power times 2x dx. Now, if the binomial weren't x squared plus 1, if it were just x, we might be able to easily find this integral. However, because we have that binomial raised to the third power, it's a little bit more complex. We have the choice of taking that, multiplying it by itself 3 times, then distributing the 2x. That's a lot of work. And sometimes, quite frankly, there isn't even enough work for us to do to be able to find the integral without using substitution. So we're going to practice doing that. You can kind of think of it as if you've got a situation where your derivative would require the chain rule, then you're likely going to need to use substitution in order to integrate. So here we have u. We're going to let u equal x squared plus 1 because that x squared plus 1 is really complicating things. If I just had u cubed, it would be so much better. Then the derivative of u is equal to 2x, right? 2x dx. Don't forget your differential. So u equals x squared plus 1, du equals 2x dx. Now look at what we're going to do here. So du is equal to 2x dx. This color is going to hopefully help you see that now we have the integral of u cubed times du. And from here, much easier to integrate. We add 1 to our exponent, divide by the new exponent, plus c. The only thing left to do is to substitute back in the part that was a little bit complex, that x squared plus 1. So we're going to substitute x squared plus 1 back in so that we get x squared plus 1 raised to the 4th power all over 4 plus c. The textbook publishers, when you check your answer in the back of the book, they might put 1/4 and then x squared plus 1 raised to the 4th power plus c. Either one is a good answer. So that's the gist of u substitution. Let's do some examples. So we're going to look for the more complicated portion, the more complicated factor inside the integral, and then we're going to take its derivative and see if that's what we have left over. So when I look at this, I see the 3x minus 1. That part is making that 4th power more complicated. If this was just 3x to the 4th power, it would be much easier. We could do 3x to the 4th power, that's 81x to the 4th power. But 3x minus 1 to the 4th power, we'd have to multiply, lots of work to do there. So what would happen if I said, well, let u equal 3x minus 1? What would du be? Du would be 3 dx. And look at there, 3 dx is exactly what's left over. So now we can rewrite this as u to the 4th power times du. Now you might be saying, where does that come from? Well, hopefully this will make it a little bit clearer for you if you're wondering. If I just rewrite this, 3x minus 1 raised to the 4th power times 3 dx, then hopefully you can see that 3 dx, that's du, and this 3x minus 1, that's u to the 4th power. And then we integrate u to the 5th divided by 5 plus c. We substitute. We have to substitute back in. That's an arrow sign. We're going to substitute back in 3x minus 1. So instead of u to the 5th power, we have 3x minus 1 to the 5th power divided by 5 plus c. Okay, let's look at the example to the right. We have the integral of 2x plus 1 times x squared plus x dx. What do you think we can let u equal? Well, we've got two binomials. If we let u equal 2x plus 1, then du is going to be 2 dx, and that's not what I have left over. I have x squared plus x dx. Well, what if we let u equal x squared plus x? Then du would equal 2x plus 1 dx. And that's exactly what we have. So I'm going to rewrite this so that you can see x squared plus x times 2x plus 1 dx. I just rewrote it in a different order. Here's our du. So here's du. And here is our u. So we're going to have u times du. U du. And u du, the integral of that, is u squared over 2 plus c. So we rewrite that, substituting back in x squared plus x squared plus x raised to the second power instead of u squared, x squared plus x squared over 2 plus c. Now we're still working with indefinite integrals, so plus c is very necessary at the end. Okay, here's another example. We have the integral of 3x squared times the square root of x cubed minus 2 dx. So we have to determine, I can see two parts here. Are we going to let u equal 3x squared? Or will we let u equal x cubed minus 2? Well, the higher degree is the one we're going to go with, because when you take the derivative, you get a lower degree. So if we let x cubed minus 2 equal u, then du is going to equal 3x squared dx. So there's our 3x squared dx, that's du. And now instead of the square root of x cubed minus 2, we're going to have the integral of the square root of u du. The square root of u is u to the 1/2. And the integral of u to the 1/2 is u to the 3/2 divided by 3/2 is the same thing as multiplying by 2/3. And then I'm going to substitute x cubed minus 2 back in, and we get 2 times the quantity, x cubed minus 2 raised to the 3/2 power, all over 3 plus c. Now, because we've got this complicated numerator, I think it's going to look nicer if I put 2/3 and then x cubed minus 2 in the middle. But it's important to note that either way you write the answer, it is correct. Now this fraction looks a little daunting, but keep going with exactly what we've done in all of these examples. Okay? We're looking for one portion of the function to let be equal to u, and then to take that derivative to be the remaining portion of the function. So I can see I have a negative 4x, and then I can see that I have this expression 1 minus 2x squared. And if I take the derivative of x squared, I'm going to get an x. Hopefully, I'm going to get exactly what we need here. And it looks like u is going to equal 1 minus 2x squared, and du will equal negative 4x dx. I'm going to highlight that. That's du. Very good. And then we're going to have 1 over, so I'm going to rewrite this. The negative 4x dx is going to become du. And then I have 1 over u squared. See, this part right here is u. Let's do that in a different color. That's u, so I'm going to have u squared in the denominator. U squared in the denominator. And then we know how to integrate this. We're going to rewrite it as u to the negative 2. And then we're going to add 1, which will be negative 1, divided by negative 1. And then we substitute back in 1 minus 2x squared for u. So we're going to have 1 minus 2x squared raised to the negative 1 power. And that negative 1 in the denominator, I'll put that in the numerator. I would really like to make this negative 1 power a positive. So I'm going to say negative 1 over 1 minus 2x squared. And since it's to the first power, I don't have to write that, and then plus c at the end.